by P over 2. That's why your reaction over here, down here is also P over 2. This is also what? P over 2. Okay. So this is our shear force equation or shear force diagram. So this is where we just drew 0 to L over X. So this over here is V as a function of X. It's a constant. This is equal to P over 2. And then we look at the next diagram, the bending moment diagram. So the bending moment diagram, I'm only going to focus on the positive side. Okay, I'm not going to look at the negative. So I'm going to look at positive. So X, right? So this is your moment over here. This is your L over 2. And over here, this is your L. So over here, if you look at this, right, the function is a linear equation. When X is equal to 0, we have 0. And at the other end, L is also equal to 0. So over here, you will have a straight line relationship. And then you will have a straight line coming down. Yeah, not really straight. Okay, it's a linear function. So what you have over here, M max is equal to P over 2 multiplied by L over 2. So this is equal to PL over 4. Okay. So this is a simply supported beam. Okay. On the left hand side. So now let's look at the cantilever beam now. Let's look at the cantilever beam now. So remember, I told you we're going to prove this mathematically. By you only need to analyze either the left hand side or the right hand side, and you treat it equivalent to a what? To a cantilever beam. Okay, so that's why I say a simply supported beam, when you analyze it, is equivalent to a cantilever beam. So again, we do the same thing. Okay, we do like, okay, 0 X L over 2. So this is between point A and in between point B now. Okay, so again, we have our slider. We draw our structure first. Right? So this is point A. This is going by P over 2. And this is your X. And this is your V as a function of X. M as a function of X. So when you do static analysis, positive is going up, summation about forces in the Y direction. Sorry, something happened to the computer. I just got kicked out. Or can you see my screen?
No, I just see you.
We just see your webcam.
Oh, okay. I think I just got kicked out by, yeah. I'm going to share again. Okay. We're okay now, right?
Yeah.
Okay. So the equation over here, I wonder why it kicked me out. So it's between point A. Oh, whatever I've done has lost. It's okay. I'll do it again. Right. So this is my P over 2. Again, my slider is in my X. Point A. Now this is a cantilever beam. Okay. So V as a function of X. M as a function of X. We do static analysis. Summation of forces in the Y direction is equal to 0. So you have P over 2 minus by V as a function of X is equal to 0. So V as a function of X is also equal to what? P over 2. And then we do the moment. Summation of moment in the Z direction anywhere upon point X. So again, we're going to take moment over here. Okay, we're going to take moment over there. So when that's the case, you have minus px over 2 plus by m as a function of x is equal to 0. M as a function of x is equal to px over 2. So this is for cantilever beam. So if you look at the equation, okay, I'm going to highlight the equation that we should be staring at. If you look at this equation over here, and this equation when we are doing cantilever beam, they are the same, right? And then when you have this equation over here, right? And on the right hand side, we are dealing with a cantilever beam. It is the what? It is the same. The only difference is this. The only difference is this. For the cantilever beam, okay, the only difference is this. For the cantilever beam, okay, so for cantilever beam, the shear force and bending moment stops here. Okay, it stops there. It does not have the right hand side anymore. Okay, so that is why when we analyze the structure, okay, when we analyze the structure, right, we can treat it when it's simply supported. We can treat it like a cantilever beam. Okay, because the failure point is the what? Is the same. Are we clear? The failure point is the same. So for this aspect, that's why when we calculate structure analysis, right, in simpler supported beam, we only consider what? We only consider one side. We don't consider the other side at all. It's redundant. Why? Because as you can see, the left and the right, the magnitude highest is still at the center. The left and the right, the magnitude, the highest is still at the what? At the center. Right? So that's why we analyze all structural failure where the maximum bending or shear force is acting on. Now, the next thing that I want to highlight to you, why do we call it symmetrical bending? Okay, why do we call it symmetrical bending? So what is symmetrical bending? Okay, what is symmetrical bending?
It's symmetrical of the neutral axis.
You are no. That's not the right answer. Okay, but let me explain what's going on first. So let's look at symmetrical bending. What is symmetrical bending? Okay, what is?
Excuse me, sir.
Yes.
Are you writing something on screen?
Yes.
I can't see anything. Like it's frozen.
Can you see anything?
I can't see you writing.
Anyone? You can see anything?
It froze and your webcam froze.
I'm still good over here. It says 1 is on my screen.
So some of you are good, some of you are bad.
Yeah, it's okay for me here.
It started again.
Okay, it started again. It's the bandwidth. Okay, a lot of kids are watching Netflix. Okay. So what is symmetrical bending? So if we have a structure like this, right? If we have a structure like this. By the way, thank you for letting me know. Okay, this is important. Yeah.
I think I have to rejoin.
Hey.
I'm still like my screen is still frozen. I will join it again.
Okay. So don't worry. Okay, we are recorded. Okay. You can watch the video for the last 15 minutes. Don't worry about it. So if we have a structure now like this now, this is point A. And this is my point B. Now the structure has loaded with different variety now. Now we have a structure like this. Okay, and then we have another P1 here. We have another P2 here. The distance from here to here is L1. The distance from here to here, like L2. This look like your exam, yes or no? Then over here, this is your L3, and the overall dimension is L4. Okay. So if we were to find the stresses at point C, so this is my point C, and I will draw for you, okay, I will draw for you that the cross-sectional area. Okay, we'll look at, so this is our transformation. X, Y, and then we have rotation about Z. Okay, so we will have, so the formula to use is stress X is equal to mz over izz multiplied by y. Remember, I told you guys what? Don't worry about the minus sign first. Okay, later on when we do the bending moment vectors, the head of the bending moment is compression, the tail is tensile. Okay, so let's look at different cross section. So if this is y, this is z, this is rotation about x. So let's look at different cross section. Okay, so this is one cross section that we're looking at. Okay, so this is cross section number 1. Then we have cross section number 2. Okay, cross section number 2. And then we have cross section number 3. Okay, then I'm going to call all the points. So this will be my point alpha, 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 and then the next one, this will be my beta, 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 and then this is my point I. Oh, no, too thick. This is my point I. Over here is my point J. Over here is my point I. Over here is my point J. Over here is my point I. Over here my point J. Then I'm going to draw my neutral axis on my centroid. Okay, so my centroid is here. The greens are my centroid. My centroid is also here. And my centroid is here. Now, can which one tell me which one is symmetrical bending? Cross-section area 1, 2, or 3?
All of them.
All of them, yeah.
So a lot of people say 3. Who say all of them?
I said professor.
Where are you? So you say all of them are symmetrical bending, and you are absolutely right. All of them is, I know a lot of students, when I taught the other class, a lot of students say this is symmetrical bending. No, all of them are symmetrical bending. So what do I mean by symmetrical bending? All of them, which we'll do next week, I'm almost done. All of them, for all of them, all right? Stress X alpha is equal to stress X beta. Stress Xi is equal to stress xj. So when this is satisfied, we call it symmetrical one. Yeah, symmetrical bending. So the symmetrical bending has nothing to do with what? Geometry. The symmetrical bending is due to what? It's due to stress field. Okay. So when I was teaching the other class, a lot of them also say the cross section 3 is the one. No. Okay. It all depend on the what? The stress field. Okay. It all depend on the stress field. So on that note, anyone have any question before I go? Anyone? No? Yep.
When will we get our test one marks?
Next week.
All right.
Okay. If that's the case, thank you so much for your attention. I'll see you guys next. Yep. Any question?
There quiz this.
Huh?
Will there be a quiz this week?
There'll be a quiz this week. Okay. Any other questions? No. If that's the case, thank you for your patience. Thank you for your time. Go and rest. Okay. Bye-bye.
Night.
Bye.